So welcome everybody, welcome back here to the gallery stage as part of the Siemens booth at Hannover Fair 2025. Another very interesting topic and two exciting guests. We're going to be talking about how data is paving the way to autonomous production for ExxonMobil. We love it when we have fantastic partners on board, and ExxonMobil is definitely one of the front runners when it comes to the global energy transformation. And digital twins and AI are at the core when it comes to the question, how can we produce more safe, secure, and sustainable? And in this panel, we will be discussing the importance of openness, of interoperability, and why thinking and working in ecosystems is becoming a must on the way to enable autonomous production. And joining us now is the Strategy Manager, Innovation and Business Transformation at ExxonMobil, Michel Teurels. Great to have you with us, Michel. And also joining us from Siemens is the Vice President and General Manager, Process Industries Software at Siemens, Bart Morse. Bart, great to have you.
Great to have you.
So, gentlemen, how are we doing today?
Fantastic, and thank you for having us.
About all the activity on the booth.
So much going on.
We have a lot of energy, and it's about energy. Huh?
It's about energy, and you brought a lot of energy, obviously.
There we are.
Get right to the chase. Now, can you please introduce maybe ExxonMobil just real quickly? I'm pretty sure everybody's heard of ExxonMobil, but nevertheless, and elaborate a bit on your role and what drives the challenges that you're currently facing.
Happy to do so. So ExxonMobil in Europe known under the brands Esso and Mobil, in the Americas as Exxon. We're an energy company in the oil and gas sector, as well as in the transition to the renewables and the low carbon solutions. Mm-hmm. The part that I'm in is the manufacturing in the downstream, where we have a mindset of operating at a global scale, operating for eternity. We continue to maintain the assets that we have, which is the model for our refining and our chemical manufacturing, as well as the model for the low carbon solutions, the new business that is being created. Will also follow that same operations model, which is different from the upstream, where an asset has a limited lifetime. One of the unique characteristics of ExxonMobil is the scale at which we want to operate, aiming to translate that scale into the lowest cost of operations. In order to get there, one of the key drivers, the key enablers, is linked to the topic of today, is being able to get that data consistently at the global scale, and from there allowing us to develop the advanced analytics on top of that. The role that I have in this space is for this manufacturing organization, as owning the strategy and working with the product groups and the IT groups and the industry and the vendors and the suppliers to make sure that we are able to select and prioritize the right initiatives to move forward in this direction.
So, Bart, can you kind of relate from the discussions you had also with other players in the game, like BASF, Chevron, and so forth?
Yeah, I can. And first, I would like to say that when I met Michel, I really felt positive because we share the same vision. And the vision is about creating an open digital twin environment. So it's not just about Siemens. Of course, we laid a foundation, but it's also how can we make it open? And there, of course, Exxon is not unique. We see the trend, and that was your question, we see the trend in multiple industries, especially in the chemical industry and the petrochemical industry. And what we saw before, it was a lot about sustainability and reducing the CO2 footprint. It's now product carbon footprint is a very important element in the industry. But there is a new driver, more important, that is the energy price. The energy price went up really tremendously. And that makes it not just from a sustainability point of view interesting, but also now even from a financial point of view. And I think in most of the company, that is still a very important element. And what I see, companies like Lenzing as an example. Lenzing is an Austrian company. They are very active in producing fibers. And it's a circular business. So they start from woods. They have tree plantages. They have their own wood. And then they make fiber for fashion. And they do it in a sustainable way. So if you now see fashion, then it's very important that you have that eco-label on your shirt. And they are one of these vendors, and we help them by supporting them in being faster in their design, but and that is the topic of the day, being more efficient in their operational space. And the digital twin is exactly where they see the benefit in. Lansing one company, and there we see that we start in all areas, from design, from engineering, simulation, in operational with them. And by doing so, stepwise, that new company will see the benefit of that journey. And they don't just use us, but they use partners in that journey, and that is about that open design, that open platform we would like to create. And another one, and that is the last I would like to mention here, that is Lanxess, and Lanxess is at the moment in the rollout. So they standardize, and I also believe that is important, and then they have the use case, and they roll out the use case over all the production plants, and they close the loop. And they close the loop by being able, in operations, if they see in maintenance tasks and efficiency, they take that backwards into the engineering and design method. And I believe that is an element where also we have discussions on what is maybe in the next steps to be explored and maybe even to be implemented.
So obviously all players, once again, in the industry kind of face the same kind of challenges. The approaches might be a bit different or individual, depending on, once again, what you're looking at exactly. And if we look again at ExxonMobil, Michel, maybe you can tell us what a production plant might look like to you in the next 5 to 10 years. Can you let us in on that?
So that would be a very interesting confirmation in a couple of years to find out where we're heading to. A lot is already on show here today. What we have is, it starts with data. Mm-hmm. And so we have that massive data set that originates from very diverse different products that each create data, either hardware sensors or through calculations. Mm-hmm. We then bring that data together to offer advanced analytics on top of that. What that means for our operations is that in ExxonMobil case, in our brownfield environment, we're expecting to continue with human beings at the plants. Mm-hmm. We're not expecting to have a full autonomous operations, but we're expecting that the human beings at the plant will be supported by these advanced analytics. Mm-hmm. The state we will be in is that in many of the cases, the platforms will help us with autonomous decision making. Mm-hmm. And so if I compare it to driving a car, mm-hmm. we all know that the image of the full self-driving car, fantastic experience to be in a car that just gets you without a human being at the steering mm-hmm. wheel. That is not yet achievable in the time frame we're talking about, but what we will have is the equivalent of a car of adaptive cruise control. You get a lot of the decision making. Do I accelerate? Do I slow down? What happens with the distance with the car in front of me? A lot of decisions are made for us that release us and that accelerates and that improves quality.
So what do you think is needed to get there, though?
And what is needed to get there? Why haven't we done it yet? What are we waiting for? The other examples that Bart was highlighting is, in most of the cases, it's not unique to ExxonMobil. It's not something that is intellectual property, measuring a temperature somewhere in a pipe. We're not going to be the better company because we're better at doing this. It's what we're able to do with that. If we look today, the big theme happening right now in reality is AI, artificial intelligence, which is an advanced level of statistics. It's allowing us to get insights that as a human being, we take too long to find. Mm. The technology is there. The solutions are there. When every time we have a new solution from a new supplier, we spend typically a couple years and a couple $1 million to integrate it at our scale. The problem to be solved is not find a solution and deploy it at what site in one location. It's find a solution, integrate it, and deploy it at scale.
Right.
The amount of these solutions that will originate is rapidly scaling up. Even just within the fantastic Siemens booth, the amount of individual products that are showcased, it's overwhelming, it's mm-hmm. exciting. Mm-hmm. The effort it takes to stitch it all together and have the different components interoperate and integrate, that is the challenge for us that we need to solve in the next couple of years.
So Bart, what technologies are already in place and what can we expect in the midterm?
Yeah, indeed. So there is a lot, I think, today available, but also many challenges. And what today is available, I personally believe, if you look into the operational space, where I think we have already a long-lasting relationship, we have the capability to build operational intelligence tools, what we call XHQ is our product we have over there. That is one of the products. At the moment, we innovate, and on the boot you will see Accelerator. That is one of the products which will be available today as a cloud solution, but it's not just about cloud, but also about the capability, just what you said, Michael. The capability of being interoperable, not just with our own products, but also with external parties, based on standards. And the way we do it, that is a little bit different as we did it in the past. So we do not allow another to follow our data structure, but the system in place will have the capability to combine different data structures in an intelligent manner and exchange information between different systems. And then we have, and that was your question, what do we have? We have modeling software, and that is used in the ExxonMobil world, especially in the process design. But of course, the ambition is not just to have the capability to understand what is possible, but to use it in the operational space. So the system now needs to be transferred in the operational space, needs to be interoperable with our system, but also with systems already in place, our new systems selected by ExxonMobil, based on that same interoperability concept. And that is where we work on. There we have already, at the moment, concepts in place. What still needs to become? I think we are still on the journey to make our all the applications we have, engineering software comes, CMIT, simulation software, to simulate before we go live in operations, that we are really sure that what we have developed also is doing exactly what we expect, that all these systems stepwise will move into that, let's say, cloud environment. It needs not to run in the cloud, but it should have the capability to run in the cloud, that we have the advantage to have the interoperability concept available. And that is what we can do at the moment already. I think we work with multiple customers. We have proof of concept, what we need to improve, and it was the midterm, and then I also give the vision later on. But on the midterm, we have further to focus on the interoperability aspect, that the 2 million to be invested will be done by the system as such. That we share information on standards with partners. That is your responsibility, that is our responsibility. We call it the knowledge broker in between, and that knowledge broker is making the handshake between these systems, without having, at that time, ExxonMobil be involved to make sure that the two partners will synchronize with each other. That will be done by the system in place. And that is not just, I believe, in your organization important, but in all brownfield applications. Because oil and gas, I think the big potential is in the install base you have.
So speaking of the systems already in place, what technologies are you already using? What when you talk about it has to be interoperable with existing systems of your customers, what are you using, for example?
Exactly that. Bart mentions XHQ. Yeah. And so XHQ is like single pane glass. It's the visual on metrics of how the operation is going right now, as well in the past, as what we're aiming for. That is one product from one vendor. It shows the data that comes through the models. One of the very interesting cases shown here is, and it's a very tangible example of why that integration matters. When we do monitoring, when we do modeling, it gives us insights. Nothing happens until something is going to be changed in the field. And so if monitoring highlights that we need to go and replace something, is modeling highlights that we have giveaway and that we can push closer to the envelope, as long as we're not implementing that, nothing will happen.
Got it.
And so the integration of a modeling platform with an optimization platform to do the long-term planning, or with a real-time process control to actually change the settings, or to drive priority of maintenance in the field, that is when we really get to the value, and it's that integration at our scale that is the problem to be solved.
And that's the first step. The second step, and we talked in the introduction about autonomous production plants, because that is, I think, the vision we come and share. That means autonomous is not enough, it needs to be smart autonomous. The system needs to be capable to adapt to exceptions or to changes in the environment, which you can't predict, but it will happen. That system needs to be able to adopt the efficiency of my plant based on these new conditions. And your question was, what can we do? And that is exactly where the model comes in place. So we have the capability to look into the operational equipment, combining it with a model. I can see what's going on, but I can also see what is different from what I expect that the system should do. And with that deviation, the model is so intelligent that it will move that operational equipment back into what we call design space, but that is in the most efficient way to run that equipment or plant in the most, let's say, energy reduced, but also highest throughput way of producing, in this case, oil and gas. And what I believe is important, that is not just about running it, but it's also about, and then there is a topic we didn't touch, about having an understanding about the condition of my equipment. So it's not just running it in an efficient way, but maybe my equipment, compared with the car you started from, will give me some signs that in a couple of days my equipment will not run as efficient as it should be. Typically you can identify that. And that also needs to be included in the concept at the moment we develop together. That is the model, the operational intelligence, and the maintenance aspect. And that's total will give you, at the end, a more efficient way of producing, which can then also be used in the closed loop to planning and scheduling activities, that you can predict the output of all these modifications you do not expect in a better manner.
Okay, so one more. What do you think are the overall benefits on the one side for Exxon, for Siemens, but also for society?
So benefits as an operator, being able to drastically reduce time to value. Today, between seeing a great opportunity in a mess like today and bringing it at scale in productions, fully deployed and fully integrated, we're talking years. We need to be able to reduce that time to value. We need to, every time we add a new application, we cannot add all the maintenance effort to maintain the configuration in every system separately. So there we're expecting a major step forward, which obviously reduces our cost. The cost then translates into more opportunities. In the business model of ExxonMobil, we're maintaining the hydrocarbon energy model because, first of all, we need the society needs the energy today, and we haven't fully been able to transition at scale, but it's also funding the transition into the low carbon solution. So getting that mechanism to work is super important for our company, but also for the business and the industry itself.
And for Siemens?
Maybe as I may put on top of it, I think nearly all products you will see here, or we drive with, or the table, it's all starting from oil. So what we do, it's not just about making it more efficient, but we reduce, where I started from, product carbon footprint. So for the society, we do something good because we make the production process more efficient. So that means all the products we see over here have a reduced carbon footprint. And I think that is one of the pillars within Siemens where we are proud of. And that is also one of the technology drivers we have, that we support oil and gas companies and others, of course, to make that become reality. Besides the financials, of course, which is also important. And also for us as a user, we do want to pay a little bit less for oil and gas at the end.
Yes, absolutely.
So paving the way once again to autonomous production for ExxonMobil not only benefits ExxonMobil, but also Siemens, and in the end, society as a whole.
There we go.
Gentlemen, thank you very much for joining us. I hope you enjoyed it also, ladies and gentlemen. And just in case you do want to check it out, once again, feel free to visit us here in Hall 9. We're still here the entire week. And then you might be able to talk to Michel or also Bart personally. Once again, thanks and continued success on this fantastic partnership.
Thank you, Michael.
Thank you for the opportunity.
Thank you, gentlemen.
Thank you.
Thank you.